Now let's see how we evaluate the performance of regression machine learning models. There are three metrics that we normally use. The first one is called mean absolute error. To measure the performance of a regression model, we can use a linear function. So if we have a series of data points that you can see as blue dots at the right side of the screen, your linear function will produce a line such as the green line that you see on the screen. So to calculate the mean absolute error, we measure the distance of actual values, which are the blue dots, to the predicted value, which is on that green line, and we just sum that up and divide it by the number of data points. So that means that a lower mean absolute error indicates that the model has made smaller prediction errors. We also have a measure called mean squared error. Mean squared error is similar to mean absolute error, except that we square the distances. The reason that we square the distances is that, first of all, we don't want the negative values, neutralize the positive values. And the second one is that we want to penalize the larger errors. And MSE is therefore useful when you want to penalize larger errors more heavily. The third metric is called root mean squared error, which is basically just the root of mean squared error, and we do that to make the value more interpretable. Now let's look at this example. Imagine that we have 5 data points and we have given these 5 data points to a regression model, and it has given us predictions. So in this table at the right side of the screen, you can see the actual values as well as predicted values. To calculate mean absolute error, we just measure the distances and sum them and divide them by 5, which is the number of data points. So the distances are 1, 1, 3, 2, and 1, and divided by 5, our mean absolute error is 1.6. To calculate the mean squared error, we use the same formula, except that we square every distance. So the distances will be 1, 1, 9, 4, and 1 divided by 5. Our mean squared error will be 3.2. And to calculate the root mean squared error, we just root 3.2 and it becomes 1.79. Now let's go to the next lecture and deep dive into bias variance trade-off.